So it's the first thing here, x times the derivative of this. Shh. Okay, so when we go to take the derivative of this, we have to use the chain rule. So it's something to the negative 1/3 power. So what do we do with this negative 1/3? Pull it out front. Leave what's inside. And then our new power, and don't forget this power. Some people will remember to bring that power up front, but they'll forget to subtract their exponent there. So please don't do that, okay? What should our new power be here? Negative 4/3, right? Yeah, negative 1/3, take away 1 is negative 4/3. Times the derivative of what's inside. 2x. Okay? So that, again, that was the first thing times the derivative of the second thing. There it is. All at once. Any questions on that first step? Just where we got things from, where it came from. This is not easy stuff. I get it. There's a lot of steps going on here. Any questions on any of this? All right, then plus the second thing here, x squared plus 4 to the negative 1/3 times the derivative of the first thing, so it's just plain old 1. So now looking at this, we're done. We've taken the derivative. So if this is a free response question and you are asked to take the derivative, or let's say, for example, that you want to find the value of the derivative at a specific point, like x equals 2, then at this point you can go ahead and just find f prime of 2, plug in the 2's for all the x's. Okay, if it's a free response question, you can literally just put the 2's in and then stop. You don't even have to simplify if it's free response. Okay. But since we're here, we're going to simplify this, okay, to get the practice of simplifying. So if we look, I have two terms that are separated by addition, right? This one big product here, this little or smaller product here, okay? Is there anything in common to these two things? An x squared plus 4. So I'm going to factor out an x squared plus 4. What power of x squared plus 4 am I going to factor out, though?
Negative 4/3.
Yeah, negative 4/3. That's the smaller power here. Believe it or not, right? It's more negative, right? Negative 4/3 is actually smaller than negative 1/3. It's more negative. So if I factor that out, it's negative-er. If I factor that out from here, what's left over? Well, still have the x, still have the negative 1/3, still have the 2x. If I factor negative 4/3 out from here, what's negative 1/3 take away negative 4/3? Well, that's plus positive 4/3. So what am I left with? Yeah, 1. Wow.
Oh, wow.
That's pretty nice, right? We got rid of that, like 2 nasty fraction exponents. Now we only have 1 nasty fraction exponent.
Oh, no, it's still 2.
So x squared plus 4 to the negative 4/3, and then let's see here. 2x times x, 2x squared times negative 1/3. So we have negative 2/3 x squared plus x squared plus 4. Right? Negative 2 times negative 1/3, negative 2/3, x times x gives you x squared plus x squared plus 4 because they're raised to the 1 power. And then these two can be combined together too, right? So remember, this is a 1x squared, so what's 1 plus negative 2/3? 1/3. So I get 1/3 x squared plus 4, and I'm going to put that all over x squared plus 4 to the 4/3. And there's our derivative. Now imagine having to do that with the delta x stuff, right? Limit as delta x approaches 0.
You hinted to
Sorry, one more time? Like x squared over 3, you mean? Or
Yeah.
you said...
Like x squared in the numerator of the entire fraction and 3 on the bottom.
You could do x squared over 3 and then plus 4 on the side, but you want to put the 3 down here? Okay. We can't do that because this 1/3 is only with the x squared and not also with the 4. When you put the 3 down there, that means both these things have the 1/3 there. You see that, Anna? So good question. Yeah, only if, Anna, we factored out a 1/3 from the top, then the 3 could go down to the bottom. Or if you broke the fraction up, if you made it 1/3 x squared over this plus 4 over x squared plus 4 over that, then you put the 3 down there. But as it's currently written, because the 1/3 is only with the x squared, you have that addition, you can't move it down. Okay, did everyone see that? Everyone understand that? Anna was asking, can we move this 3 down here? And the answer is no, because that 1/3 x squared, it's being added to 4, so this 1/3, it's not multiplying the whole numerator, it's just the x squared, so we can't move the whole thing down. All right, one second. Tyler?
So when you do the product rule, you're actually using the chain rule to find part of the product rule?
Yeah, in this case, because when we go to this very first, so when I had it rewritten as a product, when we went to go do our derivatives and stuff, I did the first thing times the derivative of the second thing. When I went to do the derivative of this thing, I had to use the chain rule to do that derivative, right? And then it was plus the second thing times the derivative of the first thing. That did not require a chain rule, it was just one, so... But yeah, that's how it kind of popped up there. Yeah, awesome.
So is it acceptable to have a complex fraction like this in your final answer?
I mean, with 1/3, I think so, yes. If we really wanted to, we could factor 1/3 out. It would be 1/3 times x squared plus 12 over x squared plus 4 to the 4/3, and then we can move the 3 down. That would be the quick step to fix it, So then we could do what Anna wanted to do. I don't like that. So then we could do that too. I think it's okay to leave it like that though. Okay, so there that is. All right, let's do another one. Letter B. Letter B. Letter B. All right, y equals. I found a similar one, I think.
You're looking straight wacky out there.
Is that an x squared plus 3 on the bottom?
Yeah, x squared plus 3. Okay, so this is very similar to the question that Tyler asked about, number 33 from the homework. Very similar setup. So the quotient rule is actually inside of like a power rule here. Nate, question?
Is that a 5 or a 3?
This is a 3, and this is a 3.
Okay.
Sorry. So, because the outermost piece, again, for the layers that we were talking about, the outermost layer here is what? The square. So, what we're taking here, the first thing we're going to take the derivative of, when I go to take the derivative here, it's going to be the derivative of something squared. What is the derivative of something squared?
2 and then that's something.
So 2, right, the 2 comes out front, times that something, to the what power?
First one.
To the 1, times the derivative of what's inside. When I go to take the derivative of what's inside, we have to use the quotient rule. That's right, Jack, exactly right. So, bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay. This is like as bad as it gets, guys, okay? So I know you're like, oh my gosh, and then there's the test, and the test is going to have like 2 of these together, so it'll be like a product rule, a chain rule, a quotient rule, kind of thing. No, it won't do that, okay? It's too much. That is, as Brittany would say, too much. All right, so we got it. Let's simplify this sum. Let's do it, okay? So I want to focus on simplifying this. Yes, we need to rewrite everything else. If you don't rewrite everything else, it's really not right, it's wrong, but also you'll forget it if you don't continue to rewrite stuff. So the 3 distributes here, yeah?
Yeah.
3x squared plus 9. The 2x distributes, but then what else distributes here to the second stuff? We also have this minus sign here. So it's become minus 6x squared, but plus 2x. Okay, the 2x times the 3x gives us 6x squared, but it's minus 6x squared. The 2x times the minus 1 gives us a negative 2x, but then it's minus negative 2x, so it's really plus 2x. All over x squared plus 3 quantity squared. Okay. I know it's a lot of algebra. Right, in fact, we were done with the calculus right there. That was the calculus. Done. So now we're just doing algebra.
So on a test, could we just...
In some cases, yes, the calculus part will be easier than the algebra. I mean, again, it depends on what you're being asked to find. If it's a free response question, you are done right there. You did what the question asked you to do. However, for multiple choice, you need to be able to match it up. And I can almost guarantee that this will not be a multiple choice answer. It'll be simplified. And because you can simplify it here. For example, we can still combine like terms in this numerator up here, can we not? Right? So we get 3x squared minus 6x squared gives us negative 3x squared. I'm going to put plus 2x plus 9.
Is that pretty much as much simplifying as it's going to ask us to do?
We can do a little bit more here.
Oh yeah, we can do more.
So we're not going to FOIL out the numerator. I would not FOIL that out. All right, let's see. Does this factor? Negative 3x squared plus 2x plus 9. Let's see here. Negative 3x times x. Let's see. 9. I don't think this factors. 3x. Yeah, I don't think it's going to factor. So we'll have to leave that. So we'll leave 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 all over. What's my new denominator going to be? Yeah, because we have the same denominators there. When we multiply, we'll just make it cubed. Okay, x squared plus 3 cubed. And that, you could probably stop right there. Yeah. Because the quadratic formula, while it might give us, solutions when this is equal to 0, factoring it, I don't think it's going to, we could, yeah. I mean, it's a legitimate question, though, too. Why wouldn't we?
Oh, I have a question. Can you go, like, I know how we go from the derivative, like, you take the first derivative and the second derivative. Is there a way to go from the second derivative to the first derivative without just, like, doing exact steps backwards?
Like, if you have a second derivative and you want to find the first derivative?
Like here's the second derivative, like, especially like a particle problem, like, they give you velocity.
And you want to find position?
Yeah.
We'll worry about that later. That's the second half of calculus. It's called integration. Going backwards. Okay? So, again, this is about as bad as you guys can expect to be able to do things. If you feel like you went through this and you understood it, that's a victory right there. Okay? If you feel like you went through this and you could do it on your own, that's a huge victory. Okay? If you really feel like you could do that on your own without making mistakes, that's good. It's very easy to miss things. Okay? If you're not there yet, like if you don't think you could do this on your own, that's okay. You need to get to that point. But if you understood it, that's a victory in itself. If you were able to follow along with all that and it made sense, that's a victory right there in itself. Okay?
Do we have a test date yet?
No, not yet. Yeah, no. Then we don't have that either. Okay, so now let's look at some more stuff. So, let's find the second derivative.
What?
Alright, I'm doing this one all by myself. I'm getting to the right time.
Whoops. I totally transposed numbers here, sorry. There you go.
The 5x squared.
Yeah, 5x squared plus 3 equals 8. Or to the 8th. 5x squared plus 3 to the 8th power. Excuse me.
big numbers in these. Oh, let's just make it bigger. Maybe I'm not gonna say it. Oh, yeah. Okay. No, it's product rule. Okay.
All right, so let's pick somebody here. So Jack, in order to find the second derivative, we first have to find the first derivative. Okay, so I'm going to call this one dy dx, just to change it up on us. That's fine.
I got 80x times the quantity of 5x squared plus 3.
All right, so lead me through. So that was your final answer. Give me like what you did here first.
Alright, so I took the 8
Okay.
out front.
Okay, out front. So 8 times.
5x squared plus 3.
Okay. Very good. He did not forget the 7th there. That's good. Times 10x, which then you said yielded.
80x times quantity of 5x squared plus 3.
There you go. Perfect.
Yeah.
Okay. Thank you, Jack. All right, Brandon. Now to find the second derivative, which is labeled, which we would call d squared y dx squared, right, using this notation. What do we have now that we didn't have before? What rule are we going to have to use we didn't have to use before? Yeah, we got a product rule going in here now. Okay. Before it was just a power rule with the chain rule in there, but here now we have a product rule. So go ahead. How are we going to start here? So the first thing, so there's our first thing, and we're going to multiply by the derivative of this second thing, right? Okay, so what will it be? Sorry. 7 plus 3. Very good. Again, don't forget, guys, it's very easy to bring that 7 out front and you forget to lower your power by 1 up here. Okay, don't forget that. And then times the derivative of what's inside. The derivative of what's inside is 10x. Very good. Plus, yeah. Times 80, just 80, yeah, 80. The derivative of 80x is 80. Okay, question, Ryan?
So, for the first one, I just left it at 8 times 5x squared plus 3 to the 7th times 10x.
Okay.
Would that
That should be
pretty
okay.
much work out the same?
Yeah, it should
I'm
work out
gonna
the
do it.
same.
I'm gonna
Should
do it.
end up.
Just so I
Okay.
can keep up.
So then we simplify here. So let's see here. 7 times 80 is 560. 560 times 10 is 5,600. X squared. Oh, wait a minute. Mr. Wid. We have GCFs.
A lot of them.
Right? So let's factor out the GCFs here, okay? So let me go to... So Christian, what can we factor out that's in common between these two things?
5x squared plus 3.
5x squared plus 3 to the what power?
The 6.
To the 6th. Is there anything else we factor out in common?
Can you take out 10x?
They don't both have 10x. They both do have what, though?
80.
80. Yeah, we can factor out an 80 as well. All right. So if we factor that out, like Christian said, okay, Christian, what are we left with in that from that first term then?
7x.
Yeah, so 7x and then a 10x as well. So let's go ahead and multiply that together. So 7x times 10x will give us 70x squared. Okay, plus, and then what's left over from that second term?
5x squared plus 3.
Yeah, to the 1, which is just exactly right. Just looks like a 5x squared plus 3. The 80 was gone because we factored that out.
Good question. Would it be more wise to factor out 80 instead of 10, so that you can get rid of the 7, make that smaller?
We did factor out an 80?
I chose to factor out a 10.
Oh, I see what you're
Get rid
saying.
of the 10x there, so make that this one.
It's up to you. It's up to you. I think I would still, because you...
You're just going to get a bigger number.
Exactly, you have bigger numbers, and you'll still be able to factor out from that potentially. So I would say, yeah. All right, so let's combine like terms now, right? This isn't too terrible. So 70x squared plus 5x squared, 75. X squared plus 3. And so there it is. The x squared here.
Yeah.
So we factored out an 80 from this term. We still have an x here next to that 80, and then the 10x. So, and then the 7 for the coefficient
I
there.
didn't think on the X. Right.
Okay. Okay. So there it is. All right. Let's try another one. This one won't be as bad.
I'm not gonna believe it till I see it.
Y equals e to the sine of theta. So right now, take like 2 minutes and just take the first derivative of that. And then if you're feeling it, go ahead and do the second derivative. But do the first derivative. I'll give you like 30 seconds, maybe 60 seconds, a minute. And then we'll get someone to give me the first derivative. Yeah. Okay with these.
Can you throw the sine x out front?
Yeah.
Times what's inside, which is the sine x and cosine x. So it's sine x e times cosine x.
Sine x times e times negative cosine. Oh, yeah.
Sine to cosine is positive. So cosine is sine. So I think it's just sine x.
Why is it just e to the center?
Because
I'm not there yet. No. Chain rule.
They got a cosine.
Yeah, let's figure out sine x. So it's not sine x times e to the sine of x times cosine of x? What is the sine here in the middle?
I think.
Oh, Connor went to the bathroom.
So, Mr. Wood.
Yeah.
When you take the. So when you start doing the chain rule, so when you put the sine x out front of the e, what happens to the sine of x that was in the e?
So
does it just go away? Like,
what's the derivative?
Normally we would subtract 1, but
Careful. What's the derivative of e to the x? E to the x. What's the derivative of e to the sine x? Or e to the sine theta? E to the sine theta. Times, then the derivative wasn't sine. So it stays the same. You don't bring the power out front. You only do that when it's x to the power of something.
wait, so we don't bring it out front.
All these stupid little.
So it doesn't, wait.
So it's just e to the sine x times cosine x?
Yeah.
What?
All right, so Nate, what's our first derivative here?
I had a little bit to guess.
You took a guess, all right?
Sine of theta, e sine of theta?
Yeah, e to the sine of theta, right?
Yeah.
Yeah, exactly right, okay?
I guess right.
Yes. I don't think you guessed. You can't really just guess something like that.
Well, estimate.
All right, maybe you were
Now you have to
unsure,
be
and so you want to say a
plausible.
guess. So, yes, the derivative of e to the something, shh, listen up here, folks. Listen up. The derivative of e to the sine of theta is e to the sine of theta times the derivative of what's inside, which is cosine theta. So Nate was right. It's cosine theta times e sine theta. And then we got to do a product rule, which is debatably not nice. Except when Brandon gets to the test, and if I gave him easy problems, he gets to the test, he'll be like, Mr. Wood, you never give us one this hard. But now he'll be like, oh, these are easier because I had to do these more difficult ones. And
So this is Brandon's fault.
it's not Brandon's fault. It's Brandon, you know, he doesn't understand that later on it's going to be benefiting that I'm challenging him like this.
So I'm just confused as to why we don't bring the sign out front.
Okay, so the question was, listen up here, the question was, Austin said, why don't we bring the sign out front and then lower the sign by 1? When do we do that? When we have a derivative of the form y equals x to the something. So when we have like y equals x to the third, or x to a number I should say, then the derivative y prime is 3x squared. The derivative of, this is e to the something. When we have y equal e to like the x, y prime is e to the x times then x prime, which is then just 1. Okay, or if it's like y equals e to the f of x, that's y prime is just e to the f of x times f prime of x. It's a different rule because e is our base, not x. Okay, Brandon's right though. We got to use a product rule here. So, Caleb, I'm going to run out of room, so I'm going to go down here and do it. second derivative, Caleb. Can you lead us through it here?
Where's my middle one? Yeah. You'd have cosine theta.
Okay, so the first times.
Second, so it would be e to the sine of theta
Uh-huh.
times cosine of theta
Yeah.
plus
Plus
e to the sine of theta
e to the sine of theta
times negative sine of theta.
times negative sine theta.
Alright, that's what I got, just the other way around.
Scooch it this way. Oh, I see what you're saying. Yeah, it's because there's more light coming down from this side, so this side's brighter normally.
You put it first, it looks like minus.
Well,
Does that help?
Ooh, shakalaka.
Anyway, okay. All right, so we actually can do a little bit of simplification here, right? So, Caleb, is there any common things we could factor out? Is there a GCF we could factor out here? What's that?
E to the sine.
Yes, e to sine theta. Okay, and then that leaves us with cosine times cosine, which is really just what? Cosine squared, you got it. And then, I put a plus, but I really should have put minus, but oh well. Sine theta. Plus negative sine theta. And there it is. There she blows. Alright. Questions on anything there?
Can you go through step right above the answer again? Like,
Right here?
Just the first half of it.
How we got this?
Yeah, like just the first half. I understand the e to the sine, but the negative sine, totally.
So it's the first times the derivative of the second thing.
Oh, okay.
Derivative e to sine theta, we actually just got right here. It's that thing, right? So it just kind of basically repeats over again. Okay, so there it is, number 2. Okay, boom, second derivative. Questions on any of that?
gold.
All right, well, I want you guys to, I'm going to give you 2 more practices here, and then I'll give you guys your assignment. Okay, so find the derivative of each. Number 1. Yep. Thank you. Number 1, f of x is cosine of 3x squared plus 2. And number 2, again, this is just the derivative, not the second derivative, just the derivative. Do not do the second derivative. I mean, you can, but it's just going to be extra work. Ooh. Oops, I forgot to put the function. Okay, I'll put it there. Okay? So they are.
Why'd you write that?
Because I forgot to write it at the first, so I put it at the end.
Goes for a loop.
Yeah, x squared, 3x squared plus 2 there. Okay, so give this a shot. All right, take the derivative of both things. Take the derivative of both, please. And I'll walk around and see how you all are doing. Stuck on anything? Any help?
I'm like stuck immediately.
Yeah.
What is being multiplied?
There's nothing being multiplied, it's just that.
It's just, what?
Is that cosine times 3x squared plus 2?
No.
Oh.
So then what do you
think
do?
it's that.
Oh, for the derivative.
Why?
Because, so you take the derivative of what's outside and then multiply by the derivative of the inside. I'm pretty sure it's that.
No idea.
Okay, I'm not entirely sure.
None of us are.
Yeah, that's it.
It's a chain rule. You just take the derivative of the outside negative sign.
What's the outside?
Cosine. This is the cosine of 3x squared plus
Yeah,
2.
right.
So you take the derivative of what's on the outside, so negative sign.
Can we simplify
3x squared plus 2. I know. And then take the derivative of what multiplied by the derivative of what's inside, which is 3x squared plus 2. Is x. That's crazy, right?
Or wouldn't that be a product rule now, because that's a...
That's it.
That's
it. That's it.
If we were taking the second derivative.
Yeah.
Oh, yeah.
Did you do like the same thing for cosine?
So then with 4 to 3 cosine squared, parentheses, 14 times 4?
Wait, do you take the power out for cosine?
Right,
Right.
That's how you appreciate that.
Because you said find the second derivative,
Yeah,
and then if it's right there, it's,
No, I
Do you
promise
take the
it's
power
not
out?
like
Did you do the power rule for sine? Or for, I guess, cosine?
Yeah. Yeah, I did.
Are you sure you do that?
I'm not sure.
I think you...
So, did you, you just wanted to point that out?
Yeah.
Okay.
That's the correct methodology. Power rule is fine. On the whole.
I feel like I haven't seen one of those since like 6th grade.
So, not quite. It's going to be 3 sine squared of 4t, then times the derivative of sine of 4t, and then times the derivative of 4t squared.
It's supposed to be on
You go in layer at a time.
Say that again?
I don't know.
3 sine squared of 4t. Then times the derivative of one side, sine 4t.
I don't know if Connor is that wacky
Times the derivative of sine.
Like,
That's
did
4.
you try to do
Then
that?
you go to 9, and you multiply by the derivative, it's going to be cosine 4t. So whenever you go like that. Not easy, right?
No, it's not. So we did it wrong.
This one's
Wait, Austin, what did it say?
How are you supposed to do it?
Hold on.
So. The 3 doesn't matter like that?
Connor looking weird.
I never the next layer in though, you have to stay
Okay, here we go. I saw some good things. I saw some slight mistakes, and that's okay. The second one's kind of tricky, so we're gonna do that. All right. So let's see here. I'm gonna pick. Taking the same numbers over and over again here. All right. So yeah, Maya. I know you're fixing one there, but we're gonna look at number 1. Shh. So Maya, if you would please. Maya, is this a product rule? No, right? It's not cosine times 3x squared plus 2, even though we see the parentheses, right? Because cosine is never, it's not something like 2 itself. It's always cosine of something. So this is not product rule. What are we going to use here? What rule are we going to use? The chain rule. That's right. So what is the derivative here then, Maya, if you would please? Okay, yeah, sorry. I'm going to write the negative sign, 3x squared plus 2 times the 6x. Like this, and then, yes, you're right, it simplifies to negative 6x sine 3x squared plus 2. Okay? Maya, where did 6x come from? The derivative of what was inside. So again, you take the derivative of the outer layer, cosine's derivative is negative sine, leave what's inside, times the derivative of what's inside 6x. So there it is. Okay? Now number 2. G prime of t. All right, we're going to go to Josh. What's the outermost layer here, Josh? So you said 2 things there. What's the outermost of those 2? Sorry, so like go back to the original function. Just looking at this. What's the outermost layer of this thing? So, well, there's no this function, not the derivative. You're talking about the derivative. Looking at this. Sine is actually not the outermost layer because something is happening to the sine. It's being cubed. So, guys, this is super important here, especially with the way that we write stuff. Please listen up, okay? This sine is being cubed. So the outermost layer here, if you want to think about it, maybe, and if maybe it'll help you if you were to rewrite this. Sine cubed of 4t really means sine of 4t, that quantity is being cubed. So the outermost layer is cubed. How do you take the derivative, Josh, of something cubed? Bring the 3 out front, leave what's inside, and then what's the new exponent going to be? 2. Then we multiply by the derivative of what's inside. Okay? Cosine of 4t. Again, because the 4t is inside, we're going layer at a time, layer at a time. So we did the derivative of something cubed. Now we take the derivative of sine of something, that's cosine of that something. Then finally times the derivative of what's inside that, the derivative of 4t, 4. Okay? This is pretty complex with the layers, all right? But it leaves us with 12 equals sine squared 4t cosine 4t. Yes. So again, layers, right? Something cubed, the derivative of that is 3 times that something squared. Times the derivative of what's inside. What's the derivative of sine of 4t? Well, the derivative of sine of something is cosine of that something times the 4. You take the derivative of only a layer at a time. If you said cosine of 4 here, you took the derivative of 2 layers at the same time. Cosine and the 4t, or sine of the 4t. You see what I'm saying? So it's layer at a time, and you work your way in. So the derivative of something cubed is that something squared times 3, times the derivative of what's inside. Derivative of sine of 4t is cosine 4t, times the derivative of what's inside that, 4. So you work your way in, and you keep multiplying by the next layer in, the derivative of the next layer in, and leaving what's inside that alone. It always starts with what the outermost layer is.
So can you show them where there's exponent and it wouldn't be the outermost layer?
Sure. Because the cosine, this x plus 1 quantity squared is inside the cosine. So it'd be derivative of cosine. So it'd be so this would be, I'll just go ahead and do it, why not? Derivative of cosine is negative sine, x plus 1 quantity squared, times the derivative of what's inside, so times the derivative of this is 2, x plus 1 to the 1, times the derivative of what's inside that, which is just 1 then.
Okay. So you just take it kind of each
Yeah,
layer.
you peel off a layer each time. Every time you take a derivative, that layer is now peeled off, you then multiply by the derivative of what's inside that. Peel off that layer times the derivative of what's inside that, peel off that.
One more similar to that, please.
Yeah.
So derivatives are like onions, and onions are like oats.
Sorry, you have a question? The Shrek thing again.
Let's try.
Chain rules, right? The chain rule is like it's like an onion. They have layers.
Like an oat.
So you multiply it by the layers. The derivative of the layers.
What is the timestamp on the video for that?
Timestamp on the 3850. Okay.
That would be cosine times 1/2, or negative cosine, or no, excuse me, just cosine times 1/2 parentheses x plus 1.
So this one would be G prime would be cosine of x plus 1 to the 1/2 times the derivative of what's inside would be 1/2 x plus 1 to the negative 1/2 times then 1 if you want, but yeah, working your way in. All right. Let me give y'all your assignment, and I do want you to get started on it here.